Alright, so question 1a asks you to find the derivative of this function here. So hopefully you can identify it as a chain rule. So a chain rule from the data sheet states that dy dx is equal to dy du by du dx. So essentially what we're going to do is we're going to let u equal the inner function. So x squared minus 5x. So this little bit in here. So the outer function is still going to be y, and we're going to have that as u to the power 4. So du dx is equal to, power out the front one off the power of both of them, so this is going to be 2x minus 5. And dy du should be, power out the front, 1 off the power. So completing the chain rule, we're just going to get that dy dx is equal to, alright, so let's get dy du. So that's this guy here. So 4u cubed. And then we're just going to times that by our du dx in the orange. So du dx is 2x minus 5. So we know that u is in fact this bit here. So we substitute that back in, so we get 4 outside of x squared minus 5x to the power 3 times 2x minus 5. And I'd suggest just leaving it at that point. It's only 1 mark, so you don't need to go too far into it. Alright, so part B of question 1 gives us f of x, and it says find the derivative f dashed at a value, pi on 2. So, couple of ways to tackle this question. We could use the quotient rule or the product rule. And if we use the product rule, we just have to use negative powers. So, what I'll do is I'll use the quotient rule. So, d dx of u on v is equal to, alright, so v by du dx minus u by dv dx all divided by v squared. So let's set this up. So we'll let u be the top function, so that's x. So therefore our du dx is just 1, and v is going to be sine x, and dv dx equals, so on our formula sheet again we can see d dx of sine x goes to cos x, and now we just substitute them all into here. So we find that the dy dx is our f dashed in this case, so our f dashed x is just equal to v. So let's pull v out. So v is sine x, so we'll put him in there, sine x by du dx. So du dx we'll put in green, so that's this guy here. So it's just by 1. And then we're going to subtract away from that u, which is just x. And then we're going to multiply that by dv dx. So that's this guy here. So we're going to multiply that by cos of x. So just to neaten that up, we have f dashed x equals sine x minus x cos of x, all divided by v squared, where v was just sine of x squared. So that should also be in that top line. I just sort of got a bit lazy. So that's still divided by sine of x squared. Alright, so now it's just a matter of subbing in the pi on 2 value that we're given. So f dashed of pi on 2 is just equal to sine of pi on 2 minus pi on 2 by cos of pi on 2, all divided by sine of pi on 2 squared. Couple ways to find sine of pi on 2, so we can just use coordinates off the unit circle. So pi on 2 is going around to this point here. We know the xy coordinates for that is x is 0, y is 1. And we know that sine, if we go through the cast, is read off the y-axis. So this is the sine of x value. Now the other way you could have done that is if you're... sorry, I'm drawing a cos one there. If you're good with graphs, you'd know that that's 2 pi, that's pi, and this is pi on 2 at a height of 1. So both of those just give you that sine of pi on 2 is 1, so that's just 1, and that's just 1, or 1 squared. And cos of pi on 2, the other one I had to draw, is 0 here, so 0, 0. Or on here, we just read that off the x coordinate, so that there is cos of x. So this guy is just 0, so all we're left with is that f dashed of pi on 2 should be equal to 1 minus 0 on 1, which is just 1, and that's your final answer.